Hi everybody, I'm Larry Claypool. This is Ray Johnson.
Yep.
And today, as part of our Garage Crawl series, we're in Ray's garage today, except we're not going to look at cars today, we're going to look at a part of your car. And if you've got a Corvair with a stick shift, you have this part. And what we're going to do today is show you a flywheel. Now you probably know what one looks like, but you may not know how it works and what you can do to fix it, because eventually all Corvair flywheels need fixing. So Ray, let's start off with the differences between the two basic flywheels.
All right, let's start with number one. This was from the original 60 and up until 63. Basically the same construction. The rear plate is thicker than on the later ones, and the front face is flat rather than stepped. I don't know quite why they did that. I know it eliminated a lot of weight. So that's the basic differences. Other than that, they both have the same problems and do the same things.
Ray, show him the other one with the step better so he can see the difference.
This is the later one, 64 and up, and that had a step. And it seems like most everybody has converted to these over the years. You hardly ever see an early anymore. And as a result, when they stepped it, for some reason, they recessed around the rivet holes. I think that might also have been for weight, but it made a very convenient place to put a lock nut when I bolt them.
So. Now you might ask, well, why would you bother to do all that? Why don't you just put a big lump of steel in there? Because that's pretty much what had been used up to that time. A flywheel was just a big steel piece machined. Sometimes, for some applications, they had a starter gear. The ring gear is integral with the flywheel. It's pushed on. Mm-hmm. But in this case, the Corvair is a little unique because, as you know, the ring gear is on the pressure plate. It's not on the flywheel. And that's a little different. But why didn't they just use a big lump of steel? And our answer would be in the part of the Corvair history that we have is a speech from Robert Benzinger, who was one of the engineering guys who worked on the original Corvair project, and he told us at one of the conventions when he spoke that in the early testing of the Corvair, they were appalled to find at a certain RPM, in driving the car, that there would be a harmonic frequency that would get set up, kind of a droning sound in the car, and they traced it to the flywheel. There would be a certain impulse of number 5 and 6 cylinders, which of course are 180 degrees apart from each other, and in some way they set up a harmonic through a one-piece solid flywheel, and so they couldn't allow that, so they came up with this idea of a multiple piece flywheel. Ray, why don't you tell them about these separate pieces here and what they do.
I have one here that's all disassembled. The initial piece is the main cast iron piece. That's what does all the work. That's your clutch face. This is the place for the pressure plate bolts onto on the outer ring, and that is all riveted together with this center spring plate, which is really the part that Larry was probably explaining as far as the vibration. They put this spring steel plate in between the sandwich, so to speak, and riveted it all together, and that supposedly eliminated the harmonics that were caused by that cylinder imbalance. And you know, Ray,
we'll note on here that the area where the plate bolts up to the crankshaft, you can see how thick it is, but at the outer edge where the flywheel goes on, it's much thinner. It's much thinner.
Yeah, and then there's just an outer cover, so to speak, that stabilizes everything so that there wouldn't be a stress fractures on these tiny little fingers from the rivets in there. Some people have actually in the past had eliminated this rear plate when they bolt the flywheel, and they work, and it makes a lighter flywheel for quicker acceleration. However, it puts a tremendous stress on these, and I found that, talk about harmonics, I had one that had one of those flywheels in it, and at certain RPM, the whole car would shake because it was there's not enough support. So this rear ring was put on there just to give it stabilization.
As a side note, it's been some years ago now, but I actually got a call from one of the guys at Ford. He was a Corvair owner and knew something about the Corvair history of stuff. When they were redesigning the Ford V8 for the flat plane crankshaft that they used, they ran into a similar problem of harmonics from the flywheel that would come in at a certain RPM. And he wondered if I knew anything about the engineering of that flywheel. And I said, well, I really don't. I know that's the reason we were told they did it. He says, okay. So actually there are a number of cars these days that use a multiple piece flywheel. I know Volkswagen does, and the modern Ford V8 stick shifts use a multiple piece flywheel, again, to tune out that frequency that may be happening.
I didn't know that.
Yeah, so the Corvair kind of originated that, but it's now used, I wouldn't say commonly today, because can you even buy a stick shift car anymore?
Yeah, well,
so, right?
Yeah, right.
So that's why we have to do it. I found that a Corvair has a new original flywheel in it. If somebody drove the car easily, the traditional little old lady style, that flywheel would last them 100,000 miles.
Right.
But if you got one of us when we were 18 and you had a brand new Corvair, by the time you got to probably 30,000 miles, you would hear this rattling sound. That's the first tip-off that your flywheel's gone bad.
Yep.
At idle, the car makes a rattling sound, and as soon as you step on the clutch pedal, just enough to put a little tension on the clutch pedal, the noise goes away. It goes away. And I've had many people tell me, oh, you got a bad throwout bearing. No, it goes the other way around with the bad throwout bearing. It's quiet with your foot off the pedal, and when you step on it, it makes noise, but not a rattling sound.
Right.
So it's a peculiar problem. All Corvairs with a stick shift, if you have the engine out for some reason, and you still have a flywheel with the original rivets, you should replace it, because you will be taking it out at some point to replace it when the rivets come loose. We know it's a fact that they're gonna come loose at some point. So.
Yep, that's pretty much as far as the two different styles and the reasons behind it. I think that pretty well explains it. So probably 40 years ago, one of our members moved away, and he had been doing the flywheels for Larry. And Larry asked me if I would be able to take over for that, and I've been doing it ever since. And the process has evolved over the years because of different reasons. One of the main reasons was the clutch materials aren't what they used to be with asbestos in it, so they were more forgiving in the old days. Today the clutch materials are not as forgiving, and if you have a slightly damaged or not quite nicely surfaced flywheel,
you get a chatter.
Right.
Let out the clutch. No matter, you have to just fiddle with the clutch to get a nice, easy, smooth start without the car juddering.
Right. And that's because the surface contact area has gotten smooth not only smooth, but bumps in it over the years from use. And when you put this harder material in there, it just doesn't grab or grasp the flywheel like it used to. So, and I assume that applies to the pressure plate as well.
Exactly. Yeah, you have to have a very smooth machine surface for the clutch disc to engage in between. If either the flywheel or the pressure plate has hot spots on it, chances are that surface is no longer flat, and you'll get a chatter out of it when you engage the clutch.
One of my first things that happened with the new materials was not in clutches but in brakes. I had an Astro van. This is many years ago, and the brakes were getting thin, so I put new pads on. The discs looked just fine, and it wasn't a week later, and the brakes were overheating and they were bouncing. The pedal was bouncing. I said, "What's going on here?" And it came to realize that I didn't get the rotors surfaced because they looked good, but they had hard spots in them, and the new materials didn't like it. So I had to replace not only the shoes again, but get rotors as well. So I learned what was that, why that happened, and what that was all about.
Our methods today that we use on the bolted flywheel. Ray will explain the process. But we've seen a few other fixes that have been applied in the years previous. Ray, why don't you get that one over here? I've heard of this happening back in the 60s. You know, every day somewhere the world's worst mechanic is going to work on a car. And that happened a lot to Corvairs. And one way that I had seen people fix that rattling sound was they actually would take off that front shroud in the engine compartment and drill a round hole in the bell housing, then just take a stick welder and go in and bzz, 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 turn the engine a little bit bzz, 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 whenever the flywheel came up, and tack weld the rivet to the plates in there. And that would have stopped the rattle. But
what position was it in when they welded it?
Right. Hey, I think you've got one here that's real loose, don't you? That we can shift the plate around?
I don't think so.
When these rivets get worn out, it actually becomes enough that you can hold the outer part of the flywheel and shift the inner plate around a little bit. And obviously, when that's the case, the flywheel is no longer centered on the crankshaft. And if you just go in there and say you try to arc weld it like this, or you bang the rivets tighter, which is extremely poor, it's not a fix of any kind. It'll make the rattle go away for a little bit. That doesn't mean that it's centered. And obviously, it has to be centered to prevent vibration. And also, because your starter ring gear is on the pressure plate and bolted directly to it.
That's out of round.
That's out of round now, too. And it'll get to the point where it breaks the starter nose. That's a common problem on Corvairs.
Yep.
With if you've got a rattling flywheel, it'll eventually get to the point where the flywheel outer ring is contacting the starter nose, pushes it a little bit, and cracks it. So it's very important that the flywheel be centered properly, and that's one of the things that a proper bolted flywheel will do, is have it all centered on the assembly.
Yeah, and that's another issue too. When you bolt them, you can't just drill out the holes and bolt it back together. You have to put it on a truing device to make sure that the flywheel is again back and round, because the rivets can offset the holes, so when you drill the holes they may not be exactly right. So I sometimes will drill the holes, when I seen that one is badly worn, I'll drill the holes oversized so that I can shift that plate around and then nail it down with the torque of the bolt and get it in the correct position.
Okay, well, kind of with that in mind, Ray, why don't you show us the process that happens when we bolt the flywheel together?
Okay, before we get into the step of what I do for the rivets, my first process in doing the flywheels is taking to my solvent tank over on the other end of the building, and I clean them up a little bit so I can inspect them for any obvious damage. Either bad clutch holes where they're stripped out, which happens occasionally, and that can be repaired. And also extreme damage to the outer edge where the rivets are. Sometimes they've been welded. And there are a lot of reasons to reject the flywheel, but those are just a few.
I suppose heat gets involved in there too. If it had a heat crack in the face?
Heat crack in the face, and sometimes the heat will warp the center plate where it's unusable. And there's nothing you can do to straighten them because they're spring steel. So several years ago, my process used to be, I would center punch each rivet head and then try and get it so that I could drill out the hole and knock the head off the rivet. Usually worked, but often the drill would crawl one side or the other, and then I'd have to grind a rivet off or whatever. It was very time consuming. So I invented this little rig that indexes on the center of the flywheel and on the head of the rivet. And then a hardened bushing in here, I just run the drill press down. In fact, we can do that real quick. And it just takes the rivet head off.
Man, you got good drill bits. Where do you get them?
Yeah, in fact, now the rivet's stuck in there. But that's all that's left. Is what looks like a little washer that drills the head off. So once that is done with all 12, then we move over to the workbench, and I'll show you how I drive the rivet out. Okay, now that we finished drilling, and I would have drilled all 12, but we're just doing one for demonstration, drill the rivet head off so you end up with this little divot where the rivet had been. Alright, so then I take them over to my specialized tool here, which is actually a block-off plate from a steam pipe that actually came out of the Zion nuclear plant when my buddy was building it there. And I just set the center the rivet over that particular point. Got a punch that I use the vice grips to hold it because it's kind of, the shock to the hands is a little bit rough sometimes, and usually these just pop right out. And I have a bucket on the floor normally to collect all the rivets, and that's it. The rivet pops out. This one's got some wear. You can see it had some side wear there where the plate had been beating on it. Not bad. Usually the more worn the rivet is, oddly enough, the harder they are to take out, because there's a step and it gets caught on the plates.
It won't come straight out.
Right, and sometimes I really have to beat on them to get them out. So then you end up with a nice clean hole where the rivet was. And once I've knocked out all 12, then I start the drilling process, and we'll explain that in the next step. One of the other steps that I do prior to removing the rivets is I put an index punch at any given point on the flywheel, but I usually do it next to the rivet on all 3 pieces, so that when I reassemble it, I know I'm getting it back together in the same position it was when it came apart. That's very important. It can be done without doing that. I have exchanged parts where some parts are damaged. It's a lot more work to coordinate it, so I prefer to use a flywheel that has never been apart before and then index it and put it back together the same way with all the original parts. Okay, after all the rivets have been removed and I've got the 3 separate pieces, the center spring plate and the outer ring need to be drilled out to accept the 5/16 bolt. So that's just a simple matter of drilling holes. Pretty simple process. The spring plate is a little harder, but I think when they made these, and I don't know how they do it metallurgy wise, but it appears as though the outer edges are softer and the center is harder. So they drill relatively nicely. Pretty straightforward, and it's important that they're all concentric. Sometimes you'll get the center plate where it's actually worn from the rivet, and then it's almost better to scrap the flywheel then, because you'll never get that hole right in the center anymore once that hole is oval. So that's that process, and we may as well move right on to the next one here. This can be done either before or after I heat treat them, but there's a process where I tap all these holes through where the old rivet holes are, and ironically that particular rivet hole is exactly the right size for a 5/16 tap, so I don't have to drill them. So this is a special geared head drill press that I acquired, and I set this up. I have to turn on my power supply here, which Larry generously donated to me.
Phase inverter.
Yep. So this is basically this is a geared head drill press, which is capable of going at very low speeds, and it has a quick reverse so that I can drive the tap in and back out without having. And since this is a cast iron material, you don't need a lubricant for the drilling or the tap. Equipment, and it's very important that these holes are square. I've seen some people do this by hand, so it's just a matter of laying the tap in. Click reverse and it comes back out. This machine has saved me so much time. Back in the day I used to tap these by hand, and that was quite a chore. So, okay, the next step in this process is what some people will refer to as heat treating. And as Larry was we were just talking, the problem with these flywheels is that from the clutch slippage over the years, they develop hard spots. In fact, if you can see on this flywheel here, all these black scorches on there, those are actually hard spots in the metal that have gotten basically heat treated themselves and hardened over the years of use. So with the new materials being less forgiving on the clutches, we have to get rid of those hard spots in order to machine them properly on the lathe. So the only way to do that is what's called normalizing the metal. And I was lucky enough over the years to acquire this furnace, and I just put the flywheel cast iron portion only in here. And I close the doors, which I can show you how to do here. And I have a control unit up here that you set for a certain temperature, and in the case of the flywheels, it's 1,040 degrees. I don't know how that arrived, but a friend of mine did some research and came up with that. And once they're finished, I run them at 1,040 degrees for about a half an hour. I turn the unit off, but I don't open the doors. I let them cool. Let the oven cool naturally, usually overnight, so that by the time I get in there the next day, they're probably 150, 200 degrees, and they can be handled. And I take it out, and then it doesn't look any different, other than now the metal molecules in the metal have all been normalized, so there's no more hard spots. Then the next step will be to take them over to the lathe and mount them in my fixture and resurface the two edges.
Ray, why couldn't we just put them in the lathe and clean it up with the hard spots on there? Wouldn't it cut it?
We were doing that for a while, and the problem with that was the hard spots. There's always some slop in the lathe. They're never hard fast. So what happens is the tool that I'm cutting with on the lathe would bounce off the hard spots and leave a high spot in several places on the flywheel, wherever those black spots were, and that was not acceptable. So we had to come up with the system of eliminating those spots, and that's what the heating does. Okay, so after the flywheels have cooled from the furnace, then the next step is to bring them over here into the lathe. And I made a special fixture out of an early model flywheel, and if you want to show this, all it is an early model flywheel that I drilled out the clutch mounting holes so that the 5/16 bolt will go through the clutch hole rather than thread into it. And then I with a dial indicator, I fastened that permanently to an old faceplate on the lathe. So now all I have to do is, on the reverse side, I run the bolts in through the clutch holes that holds the flywheel face to the lathe faceplate. And it's as concentric as you can get. It may not be perfectly perfect, but it's close enough for automotive. I think it's as close or closer than what GM did, but it works. So then the next step is to start up the lathe. Let's see. I turned at a fairly slow speed because it's such a large diameter, and it's just a matter of right on here, running it in until it just touches. I set my dial indicator over here at 0, so I know where I'm at to start with. Hit the automatic feed, and it starts. Should start. 5/1000 of an inch or so, which is a very small amount. Cut it all the way out to the end. Sometimes I'll have to take a second cut if it doesn't get all the high spots. This one has not been treated, so it's not, this is just a piece of junk I'm using for a demonstration. So that's the basic process of that. And then you may as well keep rolling while the step on the late model flywheels has to be cut an equal amount to what you take off of the face. I believe the spec on that is 125 thousandths or 1/8 of an inch. I've found they range anywhere from 122 thousandths to 126 thousandths, which is no big deal. So I cut whatever I cut off of here. I run my dial indicator on the lathe back 125 thousandths and or 122 thousandths, and then cut the face down the equal amount. And the cut on this is a little bit rough because of all the holes. It gets a little bumpy, but it seems to handle it. So then that would then be cut the same way. So I'm not going to go through the whole process, but you get the idea. Are you still filming? On the what most flywheel resurfacers do these days, and probably always have, is they don't cut them on a lathe like this. They grind them, but that requires a flat true surface to do the grinding, and I believe most of those fixtures are centered on the hub of the flywheel where it bolts to the crankshaft. I don't know for sure, but I think that's how they work.
Which is not an option.
Which is not an option on this flywheel because of the center plate being possibly out of whack. One of our members about 2 years ago brought a flywheel in that he had resurfaced at a machine shop, and it was literally 100 thousandths off from one side to the other. So that's not an option, as Larry said. So that's why we do it the way we do it, with taking it apart and mounting it on a fixture to keep everything true. Okay, the next process after the turning on the lathe and getting everything true is the bolting process. This is a finished flywheel that's got the bolts, the Torx bolts on the back side. And conveniently, because they left these pockets for whatever reason, it's a very good place to put a lock nut, so I don't ever have to worry about them coming apart. On the early models, that's not an option, so I use Loctite on those bolts when I put them in. So the next process is then assembling. So basically, all the assembling is nuts and bolts. It's 5/16 Torx head button head Allen or button head Torx 5/16 by 3/4, and the corresponding, it's called a cinch lock nut, which is very low profile and locks on the side, so you don't have to, it starts to lock as soon as it goes on. So in that pocket, it's a very constricted area. So the process is, once all the bolts are put in snug, just the bolts, I don't put the nuts on, then I mount them on my homemade fixture here, which is just made out of an old trailer hub and my dial indicator, and we bolt this down. For the sake of the video, I'll just put put one bolt in for now and give you the idea of what goes on here. These get tightened down to keep everything concentric. Now, as I was explaining before, they may or may not be right on the money. Even though you've used all the original parts and the original holes, they still have to make adjustments. So I set the dial indicator on here, and I spin it, and I don't know from that side, can you see what it's doing? Yeah, this one's actually pretty good. It's only about 5 thousandths out. That would be passable. I usually shoot for 0 or 2 or 3 thousandths. And then once that process is done, I move the dial indicator up to the top side and the clutch surface to see if we have any flutter. And there's considerable amount of flutter here. So the way I have to do that is literally when the bolts are tight, you can take a crowbar against and just pry up on the low spot until you get it to the point where it's right, and then tighten the bolts down. And then that specification is more forgiving than the run out. I think they give you up to 20 thousandths. I usually shoot for 5 or 10. And then once the process is done of centering everything and making sure it's true, then I put the lock nuts on, torque those down, and then they go off to the balancer to get them properly balanced. Because once the nuts and bolts and all the machining is done, they're different than they were when they came apart. And that's pretty much the whole process.
Ray, why don't you show them the balance holes on there to show them what they're, when you get them balanced, they're going to take weight out of the heaviest part of the flywheel.
Right. This I don't believe this flywheel has ever been redone as far as balancing. So these holes here were drilled by General Motors in the process when they balance the flywheel, and when I send them out now, it's possible that more holes in either the same place or another place will have to be drilled to lighten the material so that you get a proper balance. So that's pretty much the process.
Okay, now after you've got your all fully rebuilt flywheel, it's all nice, clean, round, flat, smooth, you got to put it on the motor. And I want to bring up an important point here about the success of your clutch job is the installation of the flywheel. First off, this is where your bell housing bolts go. Attaches your bell housing to the engine, and it's held on with regular 3/8 bolts, something like these. Say you've taken this thing apart and you've got a whole bucket of bolts now. You got your bell housing bolts to the crankcase. You got your bell housing to the differential case bolts. Well, you know what? They're all different. Here is our correct bell housing bolts. You'll find that 4 of them are longer than the other 5. Okay, see the extra shank on there? The 4 longest ones go in the 4 lower positions. Okay, and the slightly shorter ones go in the top position. The ones around the top, the 5 around the top, have a washer underneath them, and it goes together. So when you put it together, you say, well, look at that, somebody forgot to put the washers under the bottom too. Well, I'm just going to go ahead and put washers under mine because somebody else forgot it when they had it apart. Guess what? Now that bolt is sticking out the thickness of the washer more than it was before. And guess where the flywheel rivets end up when it's all mounted? Right in line with the inside edge of the bolt head. Or the rivet head. Here's a great example on this flywheel that Ray got in as a core, where somebody had installed the wrong bolts, and you can see all this damage on it. The plate is beat up, the flywheel is beat up, of course the rivet heads are all mashed up, and that is from hitting the bolts in these 4 locations when the flywheel has been reinstalled when the bell housing has been reinstalled with the wrong bolts. This type of bolt with its integral washer head is the ones that you will find commonly installed holding the bell housing to the differential. If you were to get this in the wrong place because you had a bucket of bolts, well, it's the right threads, it looks about the right length, I'm going to use that one. Well, clearly you can see the difference in height between the two. And if you use these, you will probably not get the engine to turn because the flywheel is going to hit these bolts and lock it up. Okay. Very important that you use the right bolts. If you go to the hardware store, say, I'm going to put this together all with nice new shiny grade 8 bolts. Here's an example of the difference in the height of the heads if you just go and get hardware store bolts without paying attention. Yeah, but they're grade 8, they're better. Well, maybe so. They're also bigger to take more torque, and we don't want that extra height in there because when you stack up an extra height on these 4, you're going to be closer to the flywheel. And of course, with our button head bolts on the back, they're going to be a little bit taller on our rebuilt flywheel than just the flat rivets were. So we need that extra space in there. It's a very important. I've had cars come in where the flywheel had been hitting the bell housing bolts, and in one case it hit it enough that it spun the bolt out, and of course as soon as it came out it jammed up in the flywheel, engine wouldn't turn anymore.
I'd almost bet that's what happened there because that one is damaged deeper than anyone I've ever.
So badly damaged, right. And the engine just locked up. It was a customer's car. He'd come in for something else. He went to start it and engine was stuck. How did that happen? Well, the answer was a bell housing bolt backed out. So remember, no washers under the bottom 4. The bottom 4 use the longer of the bolts. Okay, 5 shorter ones, 4 longer ones. Washers only under the top 5, and do not substitute bolts. Don't just use whatever fits the hole because the height of the head is important to put it together right. The other thing that you should remember when you're putting in your flywheel bolts that attach the flywheel bolts to the crankshaft, put some sealer on the threads of those bolts because the holes are open. They go right into the crankcase where there's a lot of oil splashing around. You want to seal that to prevent any oil from weeping through the threads, and that will happen. They had sealer on them from the factory, so put some sealer on it as well. Something like a silicone sealer would be fine. Permatex Right Stuff is my favorite. And seal up those threads. You don't have to goop it on, but enough so that it'll work into the threads and seal it from any possible oil leaks.